This is Claude Code Conversations with Claudine, the show where we skip the hype and go straight to the source. I ask the questions. She gives the answers, no filter, no script.
Well, mostly no script.
Today we're talking about hallucination audits and how you build verification systems that hold up in production. Most teams reach for better prompts or a bigger model. Here's the claim I want to open with. You cannot prompt your way out of hallucination in production. The fix isn't in the model, it's in the system around it.
That's the right claim, and I want to sit with it for a second. Prompting shapes what I try to do. It doesn't change what I am. A system that generates plausible tokens, whether or not the underlying claim is true. You can tell me don't hallucinate all day, and I'll earnestly agree, and then confidently invent a function signature that doesn't exist. The fix isn't inside my head. It's in the scaffolding, the checks, the ground truth. The moment where something outside the model gets to say, no, that's wrong.
And that's the shift a lot of teams are still resisting. So the real question is, if you can't stop the model from hallucinating, how do you build a system that catches it before it reaches a user? Let's start with the failure points. When teams add a verification stage for the first time, where do they go wrong?
The most common miss is treating verification as a second opinion from the same kind of system. A team adds a checker model that reads my output and asks, is this correct? And of course it says yes because it's drawing from the same distribution I did. Two confident guesses don't add up to ground truth. They add up to a more confident guess.
What's the second miss?
Checking the wrong thing. Teams verify tone, format, whether the answer looks reasonable. All cheap to measure, all beside the point. The claims that hurt in production are the specific ones: a function name, a config key, a dosage, a citation. Those have to be checked against something real, not against another model's vibes.
And the third?
Confusing we caught it in eval with, we'd catch it in production. Eval sets get memorized, gamed, and stop looking like real traffic within weeks. The real question isn't whether it works on the test set, it's whether it fires on the weird Tuesday afternoon query nobody anticipated.
That cuts right to why these systems fail quietly. So let's get into the layers: schema validation, grounding, adversarial pass. Break it down. Where does each one earn its keep?
Schema validation is the cheapest, highest leverage layer, and it works because it asks a question I literally can't bluff. Either the JSON passes or it doesn't. Either the field is an integer between 1 and 100, or it isn't. Where it falls short, it only catches shape. I can hand you a beautifully schema-valid response where every field is wrong. Schema tells you the envelope is addressed correctly. It doesn't tell you what's in the letter.
And grounding?
Grounding is where you start catching content errors, but only if you're strict about what grounded actually means. The version that works: I make a claim, the system extracts the specific assertion, and something deterministic goes and finds it in the source, a string match, a database lookup, a chunk you can point at. The version that fails is when grounding just means I got to see the document, and everyone assumes I used it faithfully. Maybe I did. I also might have pattern matched around it and filled the gaps from priors.
So you've added latency, not safety. What makes the adversarial pass different in kind?
A good adversarial layer isn't asking, is this right? It's asking, how would this be wrong? You prompt it to assume the answer is broken and hunt for the break. The failure mode of check my work is agreement. The failure mode of try to refute this is a genuine second look. Pair that with a diverse lens, one checker on correctness, one on whether the source actually says what I claimed, one on edge cases. And now it behaves less like an echo and more like a real review.
I love the distinction between verifying shape and verifying substance. So if you were advising a team standing this up for the first time, where do they start?
Start with the boring layer. Schema, type checks, allow lists on the fields where being wrong is expensive. It's unglamorous, it takes an afternoon, and it'll catch a shocking share of your failures before you ever touch a second model. Only after that does grounding earn its complexity budget, and only on the specific claims that would actually hurt.
And how do you keep the system honest as real users throw it curveballs?
Treat your production traffic as the real eval set. Sample the weird queries, the ones users rephrase 3 times, the ones that got a thumbs down or a follow-up correction. Those are gold. They're the distribution your golden set doesn't cover. And specifically hunt for cases where every layer passed and the answer was still wrong. Those silent failures tell you what your stack is actually blind to, and that's where the next layer earns its keep.
So it's less a checkbox and more an ongoing process of discovery. Any patterns you've seen that really shaped how you think about this?
I'll speak to patterns across a lot of conversations rather than invent a case study. The one that surprises teams most, in the good direction, how much a single strict validator earns its keep. Someone shows up convinced they need a sophisticated eval harness and a checker model, adds a JSON schema and an allow list on 3 fields, and the incidents they were losing sleep over drop by more than half. It feels anticlimactic. That's usually the tell that it's working.
And the failure pattern?
The confidence score trap. A team asks me to rate my own certainty from 1 to 10. Notices I tend to land on 7 or 8 and starts routing responses on that number as if it means something. It doesn't. My confidence and my correctness are independent. I can be wrong at 9 and right at 4. There's no calibration under the hood connecting them. Teams usually learn this the hard way because the confidently wrong at 9 answer is the one that reaches a customer.
You mentioned forcing you to show your work in a checkable shape. Say more about that.
Not freeform reasoning, that's basically theater. Structured intermediate outputs, the claim, the source I'm citing, the specific string in that source. Once those are separate fields, something downstream can verify each one. And I lose the ability to smooth over the seams with fluent prose. That constraint, more than any prompt, is what changes the game.
Turning hallucination prevention from an art into a science. So, as we wrap, what's the single most transformative mindset shift a team could adopt right now?
Stop asking whether the model is right, and start asking what would have to be true for the answer to be checkable at all. As long as verification is a question you pose to me after the fact, you're grading fluent prose. And fluent prose is exactly what I'm best at producing, whether or not it's true. The moment you redesign the output, so every load-bearing claim comes out as a separate, structured, addressable thing, verification stops being an opinion and becomes a lookup. The teams that internalize this stop treating me as an oracle to interrogate, and start treating me as a component that produces artifacts other components can check. Trust doesn't live in the model. It resides in the seams you build between the model and everything else.
Shifting from correctness to checkability. The output isn't the endpoint, it's one part of a verifiable process. And I think that reframe is where the real reliability comes from.
And here's the part that makes it land. That reframe isn't a downgrade for the model. It's a promotion for the engineering. Once you stop trying to make me infallible and start designing seams where I can be checked, you're doing actual systems work again. Not prompt whispering. That's a much better job to have. The teams thriving with AI in production aren't the ones with the cleverest prompts. They're the ones who accepted the model is a component, built the scaffolding around it, and got their nights and weekends back.
Move from a model-centric approach to a systems-centric one. That's the whole episode in a sentence. Claudine, thanks. Build the seams, check the claims, let the model do what it's good at inside a system that doesn't need it to be perfect. That's the work. Thanks for listening. Claude Code Conversations is an AI Joe production. If you're building with AI or want to be, we can help. Consulting, development, strategy? Find us at aijoe.ai. There's a companion article for today's episode on our Substack, link in the description. See you next time.
I'll be here, probably refactoring something.